Welcome to lesson 3 times 13. My prime factorization skills. I can't help it. I have to do it. 39. Using the distributive property to simplify rational expressions. So in the last episode, we just mentioned that distribution and factorization are opposite like operations or activities, right? So yesterday, or the last episode, we were factoring, and now we're going to talk about distributing again. That is that basic rule that we see up here. A times B plus C equals AB plus AC. The A has been distributed to both of the elements that were inside the parentheses. Now, what's different about today? Well, it's this. Rational. Remember what that meant? You got the word ratio in there, rational. Remember, ratios are a type of fraction, so we're talking about fractional expressions like 2/3 or A over X or 2X over B, something like that. The rules that we play by to distribute fractions are the same that we played by when we were doing anything else. And then we've got fraction multiplication, which is pretty straightforward. You just multiply straight across. We want to make sure that we're practicing this distribution thing well. So I'm going to start with a problem here that just has numbers. And this looks like it doesn't have to be as hard as I'm going to make it, okay? But I just want to show you how you get the same answer, just to prove that this property actually does hold true. So I could add those. They have the same denominator. This would be an easy addition problem, and then multiplication at the end. So we would have 6/5 times 2/3. 6 times 2 is 12, and 5 times 3 is 15. So we should get 12/15 out of this. Okay? So let's just put that over here on the side, that this should equal 12/15, which is reducible, but there you go. Let's go ahead and do the distribution. What this meant was we'll treat 2/3 as if it's A, 4/5 as if it's B, and 2/5 as if that's C. And our rule is set right there. We need to go 2/3 times 4/5 plus 2/3 times 2/5. So a couple of little multiplication problems here. If you want to, we can keep track of everything in parentheses. Parentheses means multiply anyway. And we just multiply straight across. 2 times 4 is 8. 3 times 15. 3 times 5 is 15. And then add that to up here. 2 times 2 is 4. 3 times 5 is 15 again. Because they have the same denominator, we can add the top part. Equals 4. And there's our 12/15. And if we wanted to reduce that down, what would that be, Meridel? 12/15 turns into what? That's right, down to 4/5. Okay, but that number and that number are the same. So we got the same answer doing it by adding first and then multiplying, or by multiplying and then adding. Didn't matter. We got the same thing. Now, what we've got today is just bumping that up, making it a little bit more confusing by throwing in those letters. So let's say we had a fraction here, and we'll throw some numbers in too, just for fun, where we've got this situation right here. There's A, this is B, and this fraction here is C. So here we go. Let's do this one with distribution. X over Y has to multiply through by both of these other terms. So we'll multiply it first by x squared y, and then we plunk that operation in there. That doesn't go away. And then we'll have xy again, multiplied by the other one, xy squared. So this is probably even easier than with the numbers, because now we're just like combining these things, okay? We're just smooshing them together. And we've got 1, 2, 3 x's, right? X times x squared is x cubed if you want to. You can put your imaginary ones on anything that doesn't have an exponent. Divided by y to the 1 and y to the 1, that's 2y's, right? 2 times y times y is y squared. Over here we do the same thing. X times x is x squared. And over here y times y squared is y cubed. Now, is there any more smushing together that we can do? No, not really. Not without finding a common denominator. Not without doing a little bit more work. And they don't ask you to do that here yet. That might be useful to have one numerator and one denominator. But because y cubed is different than y squared, you should not try to smoosh them all together. Some students will try to do that, and you're going to get the wrong answer every single time. You can demonstrate that by just picking some numbers for x and y and seeing that it won't work. It won't be the same. So this one is done. Okay? You got to know when to stop sometimes. And this is the place to stop. You do not have the same denominator, so you cannot combine these the way that they are. And that's as far as you need to go. You use the distributive property, and you've got that x over y plunked into all the other pieces. So I'll just do a couple other ones with some different letters. Maybe, like I said, we'll throw some numbers in there and see how that jives with everything, just to get down the basic skills that you need in order to do these types of problems. Okay, so let's start with this one right here. Maybe you want to hit pause and copy that down. Okay. All right, here we go. So this is A, this is B, and this is C. So we just need to distribute that r squared over q into these other two terms we'll have. And I'm not going to put parentheses now, because everything's multiplication and division. You're going to have r squared times r squared over q and q to the third, multiplied, plus r squared and 7 and q cubed over q and w. That looks pretty messy, doesn't it? And there's a couple things we might want to do to clean this up a bit. Obviously, there's some stuff we can start combining together. But then with all those different letters, sometimes it's just handy, it's cleaner to put all these things in alphabetical order when we're done and we want to finish it off and have a final answer. So I'll do that too if there's any place that I can do that. All right, so over here we got r squared, and r squared becomes r to the 4th power. And q, remember there's like an imaginary 1 there, times q to the 3rd would be q to the 4th. So there's our first term. That looks good. Then over here, typically you want to put the number in front. The number will serve as like a coefficient. Okay, numbers in front of all the letters are coefficients. So let's put that 7 out in front. And then what else do we got here? We got QRS. Q goes first. Got a Q cubed and an R squared. And in the bottom we've got Q and W. And we would be almost done except for the fact that there's a Q in the numerator and a Q in the denominator. And that needs to be combined. It needs to be cleaned up as well. And if you remember our rule, if we've got one of these down in the denominator with our imaginary power of 1, we can bring it up to the numerator as long as we change the sign on it. So if we combine this piece right here, the q cubed over the q to the 1, we would have q cubed times q to the negative 1. And then those two get combined by playing the power rule. Q to the 3 minus 1, which is q to the 2, or q squared. So it's basically like we're canceling out one q out of here and one q out of there. There won't be any q's here, and then this one is reduced down 1, q squared. The denominators are not the same, so we can't combine that one anymore. That one is finished. And let me clear that off. We'll work with this one over here next. You might want to hit pause and copy that down, and then we'll go to it. Okay, there it is. There it is. Let's get to work on that one. There's A, there's B, there's C. Okay? I'll start way over here and get my B cubed over D to the negative 3 times 2B squared over D. We got subtraction now, so minus, copy the B cubed D to the negative 3 times F to the negative 3D over B. Okay, now this one's a little bit trickier because it's got those negative exponents in it. And it's really up to you whether you want to fix that now or whether you fix that later. I like to fix it first and then we'll see what happens as we go through it. But if I can get rid of that stuff, I can put things together right now. That to me seems better. Or another method would be to put just everything up in the numerator right now. And then if we have to drop something back down into the denominator later, we could do that. So let's go with that inclination, okay? Let's just put everything up in the numerator. Let's not have any of these negative well, no denominator stuff. Okay, that would mean we've got a 2 up here, and we've got our b's that can stay up top. And then both of these d's have to come up. If this d comes up, its sign changes to a positive 3. And if this d comes up, its sign changes to a negative 1. Okay, that covers all of those pieces, right? So I'm just going to work with that first and clean it up even some more. I'm going to have 2. I'm going to have b to the 3 plus 2 power, which is 5. And I'm going to have d to the 3 minus 1 power, that's 2. Everything's good there. No negative exponents. Everything's in the numerator. So there's like the first part of the answer, right? Pretty good there. We're going to have this minus at this point, and then we got to clean this bit up a bit too. And I'm going to do the same thing. I'm going to move everything into the numerator and see if there's any fixing to do later. So I've got alphabetically b cubed. This b needs to come up and become b to the negative 1. I've got d's next. D, this one moves up and becomes d to the positive 3. And this is a d to the 1 already in the numerator. And then I've got f to the negative 3. Okay? The b's will combine to the 3 minus 1 power. The d's will combine to the 3 plus 1 power. And then we've got that f to the negative 3, which now it's time to fix that. Now we're going to put that down below so that we have a positive exponent. If it moves from the numerator to the denominator, it's still a 3, but it's a positive 3. And that is that one finished. It is perfectly legit to have no denominator or denominator 1 here and have a denominator over there. You see there, it's all cleaned up. The number is in front. Positive exponents. Even if we have to drop something back down into a denominator, it's got a positive exponent and nothing else can be combined. So that one's all done. It's a little clunky, and I could have started with something else first. I could have waited to the end to do some of that moving stuff around, but as long as everything got put in its rightful place, positive exponents, alphabetical order, numbers in front, then I've got a pretty nice and clean type of answer. Okay? The pattern then can also just be extended. If there are 3 terms inside the parentheses, then the pattern can be extended. The distributive properties just keep on going. This was the case if it's A times 3 things inside, that A gets distributed to all of the pieces. AB plus AC plus AD, and on and on and on. And so they might throw in a plus and a minus in there. You just do that first thing and multiply it into everything else that's in the parentheses, and then you've done your job. So there's varying degrees of difficulties here with these in the problem set. I'll be happy to work some more out on the board for you if you got any questions, you want to check some work. But that gives you at least a few things to go off of. Keep track of all the pieces, combine what you can, simplify, and then know when to stop.